everyone, welcome to my channel. Today we will deal with classification of crystalline solids, and this is a part of CBSE curriculum for class 12. Now see, we have seen about crystalline and amorphous substances. In the amorphous substances we know that they have a short range order. Some of the solid substances are crystalline in nature. All the metallic elements like iron, copper, and some non-metallic elements sulfur, phosphorus, and some compounds like sodium chloride form the crystalline solids. The crystalline solids can be classified on the basis of nature of intermolecular forces. On the basis of nature of their intermolecular forces. And on the basis of this, they are classified into four categories. The first one is molecular solids. As the name suggests, the molecular solids have molecules as the constituent particles. Constituent particles are molecules. And they may be of more subtypes, like first one is nonpolar molecular solids. Nonpolar. So there is no polarity here. So in this what should be there? Either they are made up of atoms, only atoms, made up of atoms, in which case like as in argon, helium, that is the noble gases, or they may be molecules, molecules as in case of hydrogen, chlorine. See, I have written here hydrogen. How is hydrogen molecule? It is H2. Both the atoms are same. So here these are nonpolar molecular solids. Here the molecules are held by weak dispersion forces or London forces. Okay, they are soft. These solids are soft in nature and they are non-conductors of electricity. They have a low melting point. They have a low melting point and usually they may be found in liquid or gaseous state at room temperature and pressure. So at room temperature and pressure they are usually liquids or they are found in gaseous state. Second one is polar molecular solids. Polar, some sort of polarity will be there. These molecules are formed by polar covalent bonds. They are formed by polar covalent bonds. Molecules of substances like HCl. In these molecules we find polar covalent bond. Here the molecules are held together by stronger dipole-dipole interactions. Okay, here it is the dipole-dipole interactions which is holding together the molecules. They are solids, they are also soft and non-conductors of electricity. These are also non-conductors of electricity. Most of these are gases or liquids at room temperature. For example of this is solid SO2. Solid SO2. Their melting points are higher than those of nonpolar molecular solids. Okay. For these, melting points are higher than those of nonpolar molecular solids. Third type is hydrogen bonded molecular solids. Here the molecules have polar covalent bonds. Polar covalent bonds between hydrogen and either fluorine or oxygen or nitrogen atoms. So there are polar covalent bonds between hydrogen and either fluorine or oxygen or nitrogen atoms. So there are strong hydrogen bonding which binds the molecules of such solids as in case of ice. As in case of ice, they are non-conductors of electricity. They are non-conductors of electricity. Generally, they are volatile liquids. These hydrogen bonded molecular solids, they are volatile liquids or they are soft solids at room temperature and pressure. Next type comes ionic solids. As the name suggests, ions are the constituent particles. So how are they formed? There is three-dimensional arrangement of cations and anions. As we know, there are two types of ions, cations and the anions. So in these solids, there is three-dimensional arrangement of cations and anions. And how these ions are bound together? Since they are charged, they are bound by strong Coulombic forces, because we know that ions carry charges. Okay, so they are bound by strong Coulombic forces, Coulombic or electrostatic forces. They are hard and brittle in nature. They are very hard and brittle. They have high melting and boiling points. They have high melting and boiling points, and ions are not free to move. So if ions are not free to move, what will happen? They are electrical insulators. They are electrical insulators, but in the molten state, or if they are dissolved in water, these ions become free. So now they can move and they can conduct electricity. In which state? Either molten state or when they are dissolved in water. Next comes metallic solids. The metals are having one orderly collection of positive ions. Okay, there will be the positive ions which are surrounded by and held together by sea of free electrons. Means there is a group of free electrons, in that there will be positive ions. Here and there will be so many electrons, negatively charged electrons. In that, here and there will be positive ions. So there is a orderly collection of positive ions which are surrounded by and held together by a sea of free electrons. There are many free electrons. Okay, these electrons are mobile, means they can move, and they are evenly spread out throughout the crystal. How the electrons will be there? From where we get the electrons? Every metal atom will contribute either one or more than one electron. So all these electrons together form a group of electrons. These electrons are free, they are mobile. So they are responsible for high electrical and thermal conductivity in case of metals. Whenever we apply electric field, the electrons, what will happen to the electrons? The electrons flow. The electrons will flow among the positive ions. And when we supply heat to one portion of the metal, this thermal energy is spread throughout with the help of the free electrons. Okay. So heat is also spread uniformly, and the electrons will flow. Whenever electric field is applied, the electrons will flow through among the positive ions. Okay. So another thing is that free electrons are there. This leads to luster and also color. Okay, metals, some of the metals have color and they have luster definitely. Metals, we know, highly malleable and ductile. We can beat them into sheets. They can be drawn into wires. Next comes covalent or network solids. Covalent or network solids. There are many crystalline solids of nonmetals which are formed from the formation of covalent bonds. Means there are many atoms. Among the adjacent atoms, there is formation of covalent bond, and this happens throughout the crystal. Formation of covalent bonds between the adjacent atoms, side by side atoms, and this formation will take place throughout the crystal, and thus they are forming giant molecules. Okay, and we know that covalent bonds are strong. They are also directional in nature. Since they are strong, the atoms are held very strongly at their own position. Because of this, these solids are very hard and brittle. Since they are hard and brittle, they also have extremely high melting points, very high melting points, and may even decompose before melting. They are insulators. They do not conduct electricity. These are insulators. They will not help to conduct electricity. Diamond and silicon carbide are typical examples of this type of solids. Now graphite is there. Graphite is soft and also a conductor of electricity because of its structure. In graphite, what happens? The carbon atoms are arranged in different layers. Each atom is bonded to 3 of neighboring atoms in the same layer. So in same layer, Each atom is bonded to 3 other atoms. So fourth valence electron for each atom is present. Fourth valence electron for each atom is present and it is free to move. Because of these free electrons, graphite is a good conductor of electricity. And also, since there are different layers, these layers can slide over the other. So graphite is a soft solid and a good solid lubricant. Graphite is a soft solid and a good solid lubricant. So students, this is all about classification of crystalline solids. I hope you all could understand this topic what I discussed with you today.